Awesome. Thank you so much for the introduction. So hi everyone. Thank you for tuning in today. My talk, as was mentioned, my talk is on multi-cloud WAN federation with Consul and Kubernetes. So first, thank you for HashiCorp for organizing and giving me the opportunity to speak at HashiTalks 2023. If you have any questions throughout the talk, please write them in the chat, and I can answer them either live or after my talk. I can jump right into the chat and answer them afterwards. So what does it mean to be multi-cloud? The term multi-cloud has gained quite the popularity in recent years and has left some organizations wondering if they should be adopting a multi-cloud strategy as well. To that, I've always said, take the time to understand and fully embrace the cloud that you are currently working on. If you've migrated to the cloud recently, did you just do a lift and shift, or did you take the time to look at the offerings provided? For example, managed databases, serverless technologies, those types of things. Understanding the motive to become multi-cloud is critical, as it is not easy to fully adopt two clouds at the same time for your organization. After doing your due diligence, there are benefits for using multiple clouds. You get to leverage the best of each cloud. For example, you may find that GCP's offerings in BigQuery and Vertex AI suit your data needs better, while Azure's offerings in serverless technology with Azure Functions better suits your needs for serverless. Another benefit is increased reliability and redundancy. An outage in one cloud won't necessarily impact the services your organization has running in another cloud. In the demo later, I'll show how Consul can be used to handle data center failover. So this talk and the demo later are focused on connecting services across clouds, but the concepts used will also apply if you're in a single cloud with maybe multiple Kubernetes clusters in the same one. We'll come back to this when I go through the demo environment. So a little bit about myself, again, is kind of highlighted, but my name is Jacob Mammoliti. I'm part of the cloud engineering practice at PwC based out of Toronto. And I mostly focus on clients, helping them on their cloud journey. My GitHub handle there is there below. That is where I actually have the repository for all of the code that I'm going to be showing in the demo, from the Terraform to stand up the Kubernetes and Consul clusters to the actual source code of the applications that I'll be demoing. So have a look at my GitHub for that repo there. One thing I want to highlight too is that I'm also manage and host the HashiCorp user groups here in Toronto. So if you're in the area, definitely check out the meetup.com and sign up for the meetup that we have coming up in a month or so. So diving into Consul, we're going to be looking at two components of Consul today and how they both perform in a multi-cloud, multi-data center setup. So one component of Consul is its service discovery ability. Service discovery allows you to discover and monitor the health of services by tracking them via a service catalog that acts as a single source of truth. Now let's picture how this would be beneficial in a cloud-based environment. Looking at the image on the right as a reference, let's assume app B is an API backend that is part of some auto-scaling mechanism. This could be a GCP instance group, an Azure scale set, or even pods in a Kubernetes cluster. Not shown are the other applications that depend on the data app B provides, so they must be configured with some address to find and communicate with app B. Without a service discovery tool, one might hard-code the IPs or leverage the DNS names of app B as an upstream. While this will work, it becomes a manual effort to update those references in the event app B scales up or scales down. And especially with an auto-scaling mechanism behind it, this can happen without you even noticing. Leveraging service discovery, I can configure my dependent apps with a single DNS name that is automatically updating with active, healthy instances. Looking at this from a multi-cloud, multi-data center lens, I can leverage Consul service discovery to discover services that exist in other clouds or perhaps other services that still exist on-prem. So we discussed how we can discover services across multiple clouds and multiple data centers, but how do we actually broker that communication in a secure and reliable manner? Another component of Consul is Consul Connect, which is Consul's service mesh feature. If you look it up in the documentation, you may see Connect used interchangeably with Consul service mesh, but they reference the same thing. Simply put, a service mesh is a dedicated data plane that extracts features such as secure communication, resiliency, observability, and traffic shaping from the application and instead offers it as part of the infrastructure. Looking at our diagram on the right, we can see that an Envoy proxy has been put in front of our applications to allow us to do these things I just mentioned. In a multi-cloud, multi-data center deployment of Consul, I can now guarantee that the traffic between my applications going from cloud to cloud or app to app in the same cloud is done via a common data plane. In that data plane, I can do stuff like control which services are allowed to talk to each other. For example, I can say that service A can talk to service B, but service B cannot talk to service C. One step further, we can control communication at the layer 7 network level and declare that service A can only send post requests to service B. And specifically in Consul, this can be done with intentions. We can also control how much traffic a new version of a service gets during a new release. And finally, we get a uniform and consistent view of the traffic happening in the network. So now let's dive deeper on how Consul can be leveraged to span multiple clouds. So Consul has the concept of WAN federation, which is the act of joining two Consul data centers together. By joining these two data centers, you are paving a path to allow services in each data center to discover and communicate with one another. To give an example of where this may prove to be useful, let's picture an instance where you have services that have migrated to the cloud, but still need to communicate with services that still exist on-prem. Or maybe in a more appropriate example of this talk, you have services deployed in two different clouds for redundancy, and you want to configure something like automatic failover. Of course, these examples can be done independently without Consul. For example, you could use something like an interconnect or some other VPN tunnel. However, leveraging a tool like Consul in this case gives you a consistent single pane of glass to monitor and orchestrate these abilities. So where does the mesh gateway fit into all of this? So prior to mesh gateways, which was added in Consul 1.6, all Consul servers needed to be exposed to the wide area network. This became a bit challenging, especially in the Kubernetes settings where you had to expose the underlying hosts and their host port. With the mesh gateway, which I'll be using in the upcoming demo, you now have a dedicated secured entry point into your Consul data center. So the last slide I have before we dive into the demo, I want to paint a bit of a picture of what the demo environment is going to look like that we'll be working with. So on the left side, we have a GKE cluster that's deployed in the US East region. Consul is then deployed over top of that cluster and is acting as the primary Consul data center. A mesh gateway is also deployed alongside Consul cluster to tunnel traffic from the primary data center to any future data center that we create. On the right side, we have an AKS cluster deployed in the US West region. Consul is then deployed in that cluster and is acting as the secondary Consul data center. A mesh gateway is also deployed alongside Consul cluster to tunnel traffic between the primary data center in GCP to this data center in Azure. Now, let's look at the actual applications in our Consul service mesh as well. So in GCP, we're going to deploy a sample application that has an API backend, which is responsible for serving the front-end application that we're going to deploy afterwards in GCP. On the Azure side, we'll deploy the same front-end application, and it will retrieve its data from the backend service in GCP via the mesh gateway. Additionally, what we'll do is we'll deploy the backend service in Azure as well, and go through what a failover looks like if our backend service in GCP goes away. To service the front-end applications to clients outside, we will use a Consul ingress gateway, which is deployed both in GKE and AKS. This gateway is the single entry point for the client non-mesh traffic, as I mentioned. Finally, a global load balancing solution is used to send traffic to both ingress gateways. For this demo, I'm just using round robin DNS, as the load balancing scheme, but in a more real world scenario, you could be using something like geographic location load to direct users based on any of those requirements. So let's flip over to the Consul UI and VS Code, and we'll walk through the Consul setup first. So on the Consul UI, you can see right now that I just have three services. I have my ingress gateway, I have my mesh gateway, and Consul itself. If I click this drop-down menu here, we can see that I'm in the GCP data center, which is my primary data center, and it's also my local one because I'm hitting the Consul UI directly in GCP. But with Mesh Gateway and WAN Federation, I can also see any data centers that I also have connected to it. In my case, we also have Azure. So if I go and click the Azure data center, I can see that I also have an Ingress Gateway, my Mesh Gateway, and 3 console services as well. So let's flip back over to GCP, and we'll begin to start rolling out the application to our console service mesh. I first just want to go through the application to give a bit of background of of how this is actually going to work. So looking at our source code here, the first thing that we're going to deploy is our backend service, which really is just a Flask application with 3 routes. The first route is our health endpoint, and then we have 2 API endpoints, which give us random facts about numbers and random facts about cats. Now, going back to our front end application, it's a similar Flask application as well, but this time we just have 2 routes. One is just a health endpoint, and the second one is just a root route, which is responsible for reaching out to those backend services to retrieve the data. Now, I'm setting some environment variables here, and we'll go through those when we actually get to deploying this in Kubernetes, where it'll make a bit more sense. So let's go now into our Kubernetes deployments, and we will look at our backend deployment first. So for those that are familiar with rolling out Kubernetes deployments and looking at deployment manifests, a lot of this will look very similar. The one thing I want to kind of highlight is our annotation on line 15. And what this is effectively saying is that when I deploy this, I want my backend service to be onboarded to the console service mesh. You can set this at the global level when you deploy console to say that by default, all of your apps will be onboarded to the mesh. But just to talk about it in the demo here, I disabled that and make sure and I enforce that each application has to do it on an app by app basis. So what we can do is let's roll out our backend service first. Apply. Okay, so while that gets deployed, we should see this come up pretty quickly in the console UI, and it'll just take a few seconds for it to get healthy. While it does that, we'll flip over to the front end and talk about the deployment here because there's a bit more going on. So we have the same annotation on line 15 where we do want our front end to join the mesh. And now on line 16, we have an additional annotation, which is specifying the upstream of our backend service. And effectively what this is saying is that I want to bind the backend service on port 3000 to the local host of this front end, specifically in the GCP data center. So recently, Consul added the transparent proxy so that you don't have to specify the upstream. This works if you're in a single data center, but for when we start talking about multi-data centers, we do have to pass the upstream. And additionally, we do want to pass in the data center we want to connect to. So looking back at those environment variables that I was showing in the source code of the front-end application, you can see that we're specifying the cloud for GCP, and you'll see why when we look at this front end, why we set this. We're specifying our API endpoint to be on localhost 3000, which is really just routing back to our backend service in the console mesh. So now we can roll out our front end service. And we should see that come up pretty quickly in the console UI as well. Now that that's come up as well, you'll also see that our Ingress Gateway also has an additional upstream. Now that we've added the front-end service, and we've also added a record, we've created an ingress record in Kubernetes for our Ingress Gateway to pick up. So now let's go to our Ingress Gateway and go to our upstreams. And if I go ahead and we now see that we have our application, and it's just giving us those random number facts, which are coming from our backend while we hit our front end. Now, when I mentioned about specifying the cloud environment, you'll see that we have a banner on the top that's running in GCP. And the reason for this is when we start going to roll out our application in Azure and we start hitting our global load balancer, I want to show that we can flip back and forth between GCP and Azure without our end client ever noticing. Of course, we'll notice because we have the banner, but in a scenario where we wouldn't have this, we wouldn't have an idea as an end user which cloud we're hitting. So we've effectively done this in a single data center, right? But the next piece is how do we now discover and talk to our services that exist in Azure? So let's assume that our application is starting to become more popular in the West region that we deployed our AKS cluster in. So we want to start off by deploying just our front end in Azure, but have it talk to the back end in GCP. So we can do that by we'll switch over to our AKS cluster. And we will now go ahead and deploy this. So the front end looks basically identical as it does in the GCP environment. The only difference here is that we are specifying our cloud to be Azure. So we're now in our AKS cluster. So I can go to my AKS manifests here, and I can apply the front end. Now, if we go to our Azure data center, we should see our front end come up, and it'll just take a few seconds for it to get healthy. I can now go to the ingress gateway, go to the upstream. I can grab my Azure ingress gateway. And I can now see the application is running. I'm hitting the front end in Azure, but it's actually getting this data from my backend service in GCP. So we're effectively going through the mesh gateway to go from Azure front end through the mesh gateway to our console data center in GCP to the backend that exists in GCP. Cool. Now, the final thing we want to validate is how do I flip back and forth, right? So I talked about that global load balancer that we have in front, that it is just doing a round robin. So if I refresh this, we see now that we're effectively flipping back and forth between GCP and Azure. Now, the next thing I want to talk about is going through is failover, right? That's sort of the last piece I want to talk about and how that works in a multi-cloud, multi-data center approach with Consul. So to do that, let's assume that our application starts to become more popular. So we need to roll out a backend in Azure as well, because having that latency going from our front end to our back end across clouds just isn't working for us anymore. So easy enough, we can just go ahead and apply our backend. And the final thing that I will do is in Azure is I want to update this to now look at our Azure data center as opposed to our front end having to go back to GCP. So if I roll this out again, we can now just see that our deployment is configured. And if we do a get pods, we should see that a new one is coming online. We can see that it's unhealthy right now as a new front end comes online and our old one starts to terminate, like we can see there. So if we go back here, we should see our application is working as expected, but now our front ends are both going to a back end in their local environment. Now let's test out the automatic failover. So I'm going to go back to our GKE cluster. And what I'm going to do first is I'm going to actually scale down the backend to trigger or represent a failure for our backend service. So I'm going to scale that down. And if we go back to our console cluster in GCP, we now see that our front end has gone away. And if I do a get pods, either see it terminating or delete it, it's still terminating. But the idea is that our backend in GCP is now out of console and is getting deleted. So now if I go to my GCP, I'm going to start seeing an internal server error because our front end can't actually talk to the backend. So this is where we can use the automatic failover with Consul and what's called the service resolver. So let me open that up and we can, and I can quickly talk through it. So the service resolver is our way of doing failover for our services in our Consul cluster. Especially all this is saying is that for our backend service, if there is a request to it and there's a connection timeout of 5 seconds, let's do something. And in our case here, we're doing a failover to go and look for this service in our Azure data center. So if I go ahead and apply this now, and just make sure that it got synced. Perfect. And if I start refreshing this, we now see that our application is back online. So what's happening here is that our GCP front end is trying to reach out to the backend service in its own data center, but because it can't find it, it now knows by looking at this service resolver rule to go through the mesh gateway to the Azure data center and look for this service. And in our case, because it can find it, we're able to serve traffic again as expected to our clients. So with that, that's kind of what I wanted to show today with the Consul Service Mesh and WAN Federation across multi-cloud and multi-data center. Like I mentioned too, I did specifically do this across GCP and Azure, but the one thing I want to highlight is that all of these methodologies can be used in the same cloud as well. This could be multiple GKE clusters, multiple AKS clusters, whether you still have workloads on-prem. The concepts are still the same. So thank you very much for listening to my talk today. Like I mentioned earlier, I will be in the comments after this to answer any questions. And again, all the code that I showed here is in my GitHub repo, along with all of the Terraform code as well to stand up Consul and the GKE and AKS clusters. So thank you very much for tuning in today.